In this lesson, we're going to take a look at two things, cross sections and solids of rotation. We're going to be able to identify 3D shapes that generate a set of cross sections, and we're going to be able to identify the two-dimensional figure of a cross section of a solid. The second set we're going to take a look at is rotation. So if I rotate a 2D figure around an axis, then being able to identify the solid that it creates. First, we'll focus on cross sections. Each row represents the same shape. So if I cut a cube vertically or horizontally, it doesn't matter because all the sides are squares, you're going to get a square. If I cut a cone vertically, there's actually two different places you can cut a cone. If you intersect it through the vertex, you will get a triangle. But if you intersect it anywhere else besides the vertex, it's going to be in the shape of a trapezoid. Horizontally, you would get a circle. There are a couple other cases where if you cut it diagonally, it'll give you different shapes, and we'll take a look at that a little bit later. The next row we have is a cylinder. If we cut it vertically, it actually create a rectangle versus horizontally, it would create a circle. Rectangular prisms, because all the sides are rectangles, if you cut it vertically, you'll get a rectangle either way. It just depends if the rectangle will be longer horizontally or longer vertically. And if you cut it horizontally, it would be, again, same idea. If it was smaller rectangle or larger rectangle, depending on the orientation of the prism. The horizontal slicing of a hemisphere means that I would get a circle. If I vertically slice a rectangular pyramid, you will get a rectangle or a triangle regardless of where you cut it. If I cut it horizontally of a rectangular pyramid, it would be the shape of a rectangle. If it was a pentagonal pyramid, it'd be the same shape as the base. Pentagon in that case. If we're going to vertically slice a sphere and horizontally slice it, it'd create a circle either way. If I vertically slice a triangular prism, we would get a triangle. If we horizontally slice a triangular prism, we would get a rectangle. Vertically slicing a triangular pyramid would give us a trapezoidal shape. And if we cut it horizontally, again, it'd be parallel to the base, so it would be the same shape, which in this case is a triangle. Now, going back to the cones, there are different angles that you can cut a cone. So if I have two cones on top of each other, if I do a horizontal cross section, it would be a circle. If I cut it at a diagonal instead of vertically or horizontally, it actually creates an ellipse. Versus if I cut just diagonally through the bottom and not through the entire cone, just like part of it, then it would create a parabola. And if I have the double cone and I cut it vertically through any part that is not the vertex, it would create that hyperbola. Now we're going to get into some examples. We're going to determine the shapes created by a horizontal and vertical cross section of each figure. So if I cut this pentagonal prism vertically, it's going to give us the shape of a rectangle, and horizontally it'd be the same shape as the base, which would be a pentagon. In the next example, we have a triangular pyramid. So if I cut it vertically, it would be a triangle. If I cut it horizontally, it'd be the same shape as the base, which again is a triangle. Next example is a sphere. So regardless if I cut it vertically or horizontally, it'd be a circle. If I cut a cylinder vertically, that would give me a circle. And in this case, if I cut it horizontally, it would give me a rectangle. Now I'm going to scroll down to solids of rotation. So given a 2D shape, identify what three-dimensional solid it creates, and then if you're given a three-dimensional solid, if you can identify the two-dimensional figure. So if I rotate a triangle all the way around that axis, it's going to look like a cone. And then when it's rotating, it creates that rounded base. So our example here would be a cone. And then if I rotate a rectangle, again, it's going to give me those rounded sides. Here's my height, and then rounded side at the bottom again. So it'd be a cylinder. If I rotate the semicircle around the axis, you'll notice that it creates a circle. Maybe a little bit better than what I drew. So this would actually create a sphere because it's going around. Now, the figure generated by a rotation, notice that there's a gap between the axis and the actual three-dimensional figure. That means when I rotate around, there's actually going to be a gap in the middle of it. So it looks like it's going to have a big hole. So when I rotate that around, it's going to look like a cylinder still, like this, but it's going to have a hole through it, like that. If I rotate the circle around the axis, this one's a little bit more interesting. It'd create a shape that looks similar to a donut. So if I have the center of the donut, then this would be the outside of it.